Okay, so we're going to take a look at some examples specifically from the discussion of probability and normal distributions. And these particular problems actually deal with the inverse normal. I would strongly suggest that you all use the calculator, not the calculator, but the free website that's available through D2L. I've put the link here on this first page of the video because, guys, it is so much easier to use, even more so than the regular TI 83, 84 calculator. So I would strongly suggest that you look at using the website. But as we read this question, it says men have head breadths that are normally distributed with a mean of 6 inches and a standard deviation of 1 inch. Engineers must consider the breadths of male heads when designing motorcycle helmets. Due to financial constraints, the helmets will be designed to fit all men except those with head breadths that are in the largest 2.5%. Now, first of all, to work through this problem, you really have to be told three things initially. One is that your variable, which in this case is the head breadths of men, you have to know that it's normally distributed. You have to know the mean of the distribution, which again is stated in that first sentence, and you have to know the standard deviation. So whether you're working through a normal distribution problem or in this case an inverse normal distribution problem, you have to know those three things. You have to know that your variable is normally distributed, and the way we write that in shorthand, so I can kind of keep all of my information together. The way we write that in kind of the statistical shorthand is we say that x, which is our variable, approximates a normal distribution with a mean of 6 inches and a standard deviation of 1 inch. It's always in that format. X approximates the normal with a certain mean value and then a specific standard deviation value. I like whether I'm going to use the website or whether I'm going to use the calculator. I like to kind of draw a picture of what's going on. So I know that I have a normal distribution. So I'm going to draw the horizontal baseline. I'm going to draw the normal bell-shaped symmetrical looking curve. I'm going to label the mean, which is the measure of center and would be in the middle. Now remember that the mean of the distribution as a measure of center divides it so that I have 50% of the data values below. So 50% of men have head breadths that are smaller than 6 inches. And then I have 50% that is larger than 6 inches because the mean's in the middle. It divides it 50-50. And we're talking about designing helmets. And you may say, well, Miss Ralston, how do you know that this is an inverse norm? The biggest clue to me that I know this is an inverse norm problem is that here in the end, in this last statement, it says that we're going to make helmets for all the men except those with head breadths that are in the largest 2.5%. I start out knowing the percentage or the proportion or the probability of a particular event, and I want to know what condition is going to match or fit with that particular proportion or percentage. Now, I got to think a little bit because it says we're going to exclude men with the largest head breadths of 2.5%. Okay, so if they're largest, I hope that makes sense to you that they're going to be greater than the mean. So somewhere over here to the right of the mean, there is some cutoff score, and we're going to exclude those men who have the largest 2.5%. Now, I do need to write that percentage as a decimal. Hopefully, you remember to take 2.5, divide it by 100, and as a decimal, that's 0.025. Okay, so we're going to exclude that particular amount. So these are the people whose heads are so big that if they wanted to buy a motorcycle helmet, they would have to special order. Okay, so we're going to exclude these. Well, if we're going to exclude 2.5%, I hope you realize that means that we're going to include the other part, which means we would actually be including 97.5% of men would be able to buy these particular motorcycle helmets. Okay, now when I get ready, I'm going to use the website, and so I have to think about my question. The question is, we want to figure out what size helmets we're going to make. You know, what's the biggest size helmet that we're going to make? That would be this score here, where this cutoff is. And I want to exclude those that are larger or to the right of that number. So I want to be above, okay, because I need to know that for the calculator command. Okay, so I'm going to go out to the calculator, and in the calculator for the inverse norm, you have to enter the area that you're trying to exclude, which for us is the 2.5%, written as a decimal is 0.025. We enter the mean, which was 6 inches. We enter the standard deviation, which was 1 inch. And I want to be above that cut score. So I click the button next to above, and in the little box next to it, it says 7.96. And if you'll notice, the picture that's drawn up here looks very similar to mine. Now, it's got a bunch of extra numbers on it, but you still get the same concept as I do. Okay, so going back to the problem then, what that tells us is that the biggest helmet that we're going to make, the value comes out to be 7.96. You're asked to round that to the nearest whole, so that would be 8 inches. So the biggest helmet that this particular company would make is going to be 8 inches. And a helmet that has a head breadth of 8 inches would fit all 97.5% of all men. Okay. Now, let's look at the next question. I think it's a similar question, but they're talking about the smallest. Oops, I skipped one. I'm going to scroll back up. Okay, so it's the same question. Men have head breadths that are normally distributed with a mean of 6 inches and a standard deviation of 1 inch. Okay, so again, in this problem, I know, sorry about that, I know that the distribution is normal. Okay, so again, in my problem, it says normally distributed. It also tells me that my mean is 6 inches. Okay, whoops, getting a little trouble there with my mouse. Okay, and then it tells me that the standard deviation is 1 inch. Okay, so again, before I can work the problem, I have to know the mean, I have to know that it's normal, and I have to know the standard deviation. And again, I'm given and should be given all of those pieces of information in my problem. Again, we can write it in a shorthand, and we say that X is approximately normal with a mean of 6 and a standard deviation of 1. And it continues on and it says, engineers must consider the breadths of male heads when designing motorcycle helmets. Due to financial constraints, the helmets will be designed to fit all men except those with head breadths that are in the smallest 2.5%. Find the minimum head breadth that the helmets will fit. Okay, so the first question we were trying to find the biggest helmet that they were going to make. In this question, they're asking about the smallest helmet. So if I think about it, and I'm going to sketch me a picture here. Again, I think a picture helps you to see visually what's going on. It also can help you in terms of deciding whether you should choose the option of above, below, between, or outside. So I'm going to draw the normal distribution, my baseline, my normal distribution. The mean is in the middle, which is my measure of center, which is 6. Okay, and this time we're going to exclude men with small heads, okay? Being smaller, hopefully common sense would tell you that you're going to be less than the mean or the average. So we're going to exclude or cut off, again, we're going to exclude the smallest 2.5%. Again, you need to convert that percentage to a decimal. So you take 2.5, divide it by 100, and you get 0.025. Again, I'm going to use the website to do the calculations, okay? So again, I'm looking for what's going to be the smallest helmet size that this particular manufacturer is going to make. So I'm going back to the website. My area is still the 2.5%, or as a decimal, 0.025. The mean is still 6. Standard deviation is 1, but this time I want to be below the cutoff. So I click in the box or the dot next to below, and the answer pops up, and it comes up to be 4.04. Okay, so I know that the smallest size helmet that I'm going to make, the exact answer was 4.04. Again, if you're asked to round that to the nearest whole, that would be 4 inches. So basically, this manufacturer of motorcycle helmets are going to make the smallest helmet they make is going to be 4 inches, and the largest helmet they make is going to be 8 inches. Okay, let's look at a couple of other examples. I'll work these using the graphing calculator in case that's the method that you're choosing to use. Again, I would strongly recommend making your life easier by using the website. But this question reads, SAT scores are normally distributed with a mean of 491 and a standard deviation of 113. Again, in that first sentence, it tells us that it is normally distributed. It also tells us that the mean is 491, and it tells us that the standard deviation is 113. So again, you have the information that you need. Then it says, a university plans to send letters of recognition to those students whose scores are in the top 8%. What is the minimum score required for a letter of recognition? Okay, so I'm going to make myself some notes. Okay, so I know that my variable, which is x, is approximately normal. Okay, so x is approximately normal with a mean of 491 and a standard deviation of 113. So let me get up here where I have some space. Okay, and then I want to kind of sketch or draw a picture of what's happening here. So again, we know that it's a normal distribution, so I'm going to draw the baseline. Oops, that's kind of sloppy, so let me see if I can fix that. Okay, so I'm going to draw the baseline. I'm going to draw the bell-shaped distribution. Okay, the mean is the measure of center, so I'm going to draw a dotted line in the center, label it the mean, 491. And it says students whose scores are in the top 8%. Okay, so guys, you got to really pay attention to this phrasing. Okay, it says the top 8%. So I hope you realize that the idea of the top 8% is going to be somewhere, some cutoff score on the right or to the right of the mean, so that we're going to send letters to those who are in the top. It's the top in a sense that you're to the right side where the higher values are, 8%. Now again, even if you're going to use the calculator, you need to convert 8% to a decimal, which will be 0.08. Now, one of the big differences, or almost what makes it more difficult in using the calculator, is that for the calculator, you have to give it the area to the left of your cutoff. The command for the calculator is inverse norm. Okay? So the command for the calculator is inverse norm. And you press the blue second button, then the vars button. Okay, so we're going to look for the inverse norm command. So you go second, you're going to press the blue second button, then you press the button that says VARS, because above it in blue it has DISTR, which stands for distribution. Inverse norm is option 3. When you press the number 3, the inverse norm command comes up on your calculator. INV norm. And then it's going to want 3 different variables. And here's one of the key things here, guys. It wants the area to the left. See, the website was not that picky. The website lets you choose whether you wanted the region that was above, below, between, or outside. The calculator is only programmed for area to the left, so you have to give it the area to the left of the cutoff. Then you enter the mean, then you enter the standard deviation. So I have to go back up here and look, because the cutoff that they gave me was the top 8%. Okay, so if I'm going to send letters to the top 8%, I have to really think about what percentage are not going to get a letter. Remember, the total is 100%. 100% minus 8% would be 92%. So 92% of the students would not receive a letter. Written as a decimal, that's 0.92. So the area to the left, which I would enter into my calculator, is the 0.92. Okay, so in your calculator, you would enter inverse norm 0.92, mean is 6, standard deviation is 1. And notice that you separate each one of those numbers with a comma. So if I do that on my handheld calculator, I get a value. Oops, I'm sorry, I got the wrong mean and standard deviation in there. I reverted back to that other problem, didn't I? Alright, so let me fix that. Sorry, I reverted back to our other problem. Okay, so it should be, if Miss Ralston gets it correct, is 491 for the mean and 113 for the standard deviation. So let me type it in there correctly. Second, bars, option 3, I have 92% to the left of the cutoff, or 0.92. The mean is 491. The standard deviation is 113. And I get a score of 649. My calculator gives it to me 649.77308664. You have to pay attention because sometimes it'll ask you to round to a whole, sometimes it'll ask you to round to one decimal place. You have to pay attention. This one I would probably go to a whole, so I would round it to 650 because you have the 9 in one place. It's next door partner to the right of 7. If it's higher than 5, you round up. So students that scored 650 or higher would be in the top 8%, and they would get a letter from the school. Okay, one more. To qualify for security officers training, recruits are tested for stress tolerance. The scores are normally achieved with a mean of 62 and standard deviation of 8. If only the top 15% recruits are selected, find the cutoff score. So initially we know that it is a normal distribution until it tells that in the story. So we know that variable x is approximately normal with a mean of 62 and a standard deviation of 8. Okay, so then if I draw a picture so I can get a sense of what's going on, I draw the baseline. Again, that's going to get messy, so hold on just a second. Okay, so we draw the baseline. We draw our bell curve. The mean is in the middle, which is 62. And it says only the top 15% of recruits are selected. So again, thinking about it being at the top, that's the high end. It's going to be somewhere over here. And so the top 15% would be the ones that get selected. Again, remember, you have to convert your percentage to a decimal. So you divide by 115, divided by 100, would give me 0.15. And that top 15% does it score high enough, okay, on the test, will be able to be recruited to possibly become security officers. Okay, so again, if I'm going to use my calculator, because I have that percentage, I'm going to use the inverse norm plan. Again, knowing that percentage is a clue that you want to do inverse norm. That is probably one of the things that may be giving you guys trouble, is knowing when to use the inverse norm command, when you should use the normal CDF, or when to use the normal distribution website, and so forth. Okay, so again, if I'm thinking about my inverse norm, I need the area to the left of the cutoff. So if the top 15% gets selected, I want to think about what percent do not get selected. Remember, it's a total of 100. 100 minus 15% would be 85%. Written as a decimal would be 0.85. So it'll be inverse norm. The area to the left is the 85%. The mean is 62. The standard deviation, I believe, was 8. Okay, so the standard deviation was 8. Close up the parentheses. And then hit enter. Okay, so if I punch that in on my handheld calculator, second, bars, option 3, 0.85, comma, 62, comma, 8, close parentheses, and hit enter. We get a value of 70.291. Whoops, sorry about that. 146,704. And again, most likely you just have to pay attention. They may want you to round to 1 decimal place, 2 decimal places. This one, again, I would probably round to the nearest whole, so it would be 70. So any person who takes that particular stress-related test and scores 70 or higher could be recruited as a security officer.